Okay.
Alright, so Jonathan, on this one, what is this divergent by a p-series or convergent? 1 over n squared. Now I need you to start writing this down. This is some new information, so if you could make a group of these again. I think if it's already in your notes, you can just add around them, but look for that. So where are we? So n squared, is that convergent or divergent?
Convergent.
Right, and the n cubed?
Convergent.
And n to the fourth?
Convergent.
Okay, so Jonathan, what is the fence? Where do we jump the fence to convergent from divergent? What was the number again that you said we should look for?
The exponent.
Which is, it has to be what? That exponent.
Greater than 1.
1 is the fence. So it's actually the harmonic series that's sitting on the fence. Itself is divergent, and everything to one side of it is also divergent. The other side is convergent. So the harmonic series has important positions sitting there. It's interesting, we know that these converge. 1 over n squared converges, and we actually know the number it converges to. And it is pi squared over 6. That's not the result of a test. That's the actual number it converges to. And it took a lot of difficult math and a lot of brain power and thinking to come up with that number, and with math that I cannot explain because I don't know it. And n to the 1 over n to the fourth also converges, and it's pi to the fourth over 90. Once again, some mathematicians took a long time to come up with that. However, 1 over n cubed converges to what we do not know. We are positive that it converges, but as to date, no one knows what it converges to. So do you have a purpose for living now?
Yes.
Okay. All right. All right, so it's very interesting that there are still lots of holes in our understanding of math. It's still a growing, living organism. We're still, adding to it, and this is a spot where there's much study. So, interesting, is it not? All right, let's look at building on to what we have had so far. I think that's all the loose ends that I had. Let me check before I don't have to double back. Yeah, here we go. All right, the next test. So we have all these tests that we've come up with, and the next test is going to be called the comparison test. So when we meet again, guess what? I'll go over all these tests again. I'll grill you again on all these tests, and eventually I'll test you on the tests. So today is a new one, the comparison test. So let's see how it works and get you in a position to do some problems. All right. Let's look at this by taking one that we know the answer to. So our friend from over here, we already know that when n starts at 1 and goes to infinity, 1 over n squared does what, Brendan? Converge or diverge?
Converges.
All right, so we're pretty sure of that. So this one, however, is one we're not so sure about. 1 over n squared plus, well, let's say plus 2. I think we've done plus 1 in our assignments somewhere along the line. So let's generate a few terms of the first and of the second and compare them. So you'll see that this name will almost explain what the test is. So Gianni, give me some values that this is generating.
1/4, 1/9, 1/16,
One more.
and 1/27.
All right. All right, Morgan, I want you to do the same thing for this one. So we get 1 over 1/3.
1/6. I think. 1/11. 1/18. 127.
20 what? What were we up to? 527. You're right. All right. If you notice, there's a relationship between the first term here and the first term here. This is smaller. Does that repeat here? Is 1/6 smaller than 1/4? Is
Yeah.
1/11 smaller than 1/9? Is 1/18 smaller than 1/16? And 127, is it smaller than 25? Will it always be that way, mathematically? Because we've added a 2 here, we know that when a denominator is bigger than an original denominator, there's going to be less of those inside of the 1. So we divide 1 by a larger number than we did before, it's going to create a smaller answer. No matter where you are on the number line, that's going to be true. So if you can find, like, this would be the problem in the book. So what I have to train you to do today, and then it's easy peasy, is finding a sequence that you can compare it to. So imagine you hadn't seen this, and this was just number 1 on your assignment. You would probably pick that to compare it to. So usually the comparison rule is staring you in the face in the middle of it. So that's how you can pick it. And then you want to check and make sure that you have chosen rightly. What the comparison test says, and I'll actually write it out in words in a minute, but this time, sometimes I give you the words and then the example. I'm giving you the example and then the words this time. So what we're going to do then, the comparison test says that if you can find the relationship where one sequence is always less than the other, if this top one converges, then so does this one. Does that make sense why that's true? Converging, remember when we took that first 9.2, we had those graphs? Like suppose, I'm not going to actually graph this one, but suppose this one probably converges to 0. It wouldn't have to. Let's just pretend that there is a function out there, a series that converges to this value right here. Then if there's one that's always under it, it will converge as well. Let's do 0, because that'll make more sense. So if it converges, the top one converges, and that we know that there's one under it that's smaller, it will always converge as well. So if this converges and this is smaller than that, it will also converge. So let's write that out in words. So let's say, I'll finish this one. We'll say 1 over n squared plus 2 is always less than 1 over n squared. 1 over n squared converges. So does 1 over n squared plus 2. That's the essence of the thinking using the comparison test. So that's not too bad. Let me write it out in words for you. We need a little math ease on a Friday to ease our way out of class into home life. A little math ease never hurt. All right. This test has a requirement as well, which I did, this one met, but I didn't tell you, and that is all the terms have to be positive. So let's start with that. We can, in mathese. All right.
Miss Powell, there's some button on here that's flashing. I think it's like a low battery or something.
Okay.
I don't know what it means though.
All right, it'll turn itself off once we
If
run
it
out.
does, okay.
So just go as far as it'll go.
All right.
All right. For all positive terms, so we can only use this with positive terms, let a sub n and for a sub n, that's a series, less than or equal to b sub n, if the summation of n equals 1 to infinity of b sub n converges, then the summation as n goes from 1 to infinity of a sub n also converges. Alright, so that's how you write it in math lingo. So if you would write that in your comp books, the blue part, for all positive terms, and for a sub n always less than or equal to b sub n, if b sub n converges, then a sub n also converges. There's a flip side to that. So that's sort of like part one.
It's been 10. Should I start a new one?
Yeah, might as well.
Okay.